Hello, in this video we are going to be looking at how to solve fractional equations, or a fractional equation, using equivalent fractions. The two equivalencies or rules that I'm going to use in this are the following. If I have a number divided by itself, a fraction that is n over n or a over a, the value of that is 1. And that's reversible. I can go the other direction as well, that if I am trying to make a value of 1, I can create a fraction of a value over itself. The second fact that we're going to be using in this problem is if I have two fractions that are equivalent or equal to each other, and both of those fractions have the same denominator, as in this case, then it must be true that a and b, or the numerators, also have to be equal. So if I have two fractions that are equal and they have the same denominator, then the numerators must be equal to each other. That's the only way that equality works. So I'm using those two pieces of information to solve the following equation. So I've got 2 over x squared minus x minus 2 over x minus 1 equals 1. So the first thing I'm going to look at are these two fractions to the left here. They appear to be quite different, but actually they're not. When I look at the first denominator, x squared minus x, that is just x times x minus 1. When you distribute that x in, you get this denominator here. So I've just rewritten that. And then the second fraction, it's over x minus 1. So the only difference between these two fractions and their denominators is a factor of x. So I can make them have equivalent denominators, or equal denominators, if I multiply the second fraction by x. I'm going to do that. I'm going to do times x and times x. So I've got 2x over x minus 1. Which would allow me to combine this into one fraction now on the left-hand side. And I can leave this as x squared minus x, that's fine. On the right-hand side, I have a value of 1. This is where that rule is going to come in of the a over a. So I'm going to translate that value of 1 into a fraction that has that same denominator that we just figured out for the left-hand side. So I'm going to use that x squared minus x as my denominator and my numerator, because any value over itself is equivalent to 1, it's equal to 1. Okay, so now I have a situation that is a proportion, two different fractions equal to each other, with the additional piece of information that they have the same denominator, they're identical denominators. So that is this second rule up here. If the denominators are the same and they are equal to each other, then their numerators must be equal. So I can just drop the fractions altogether, drop the denominators altogether, and that simplifies the equation significantly. So now I just have the numerator on the left equal to the numerator on the right. And from this point, I can see I've got an x squared, so I'm going to isolate everything to one side and solve it as a quadratic. So if I leave the x squared on the right because it's positive there, add 2x, that's going to give me plus x on that side. Let the bell finish. And then this plus 2, I'm going to subtract it over to the right. I've set it all equal to 0. At this point, I'm going to factor out this quadratic on the right. So I'm looking for 2 factors, then multiply to make x squared plus x minus 2. Well, the x squared has to come from x times x. The negative 2 is likely created by 2 times 1. And I need to get a positive x as my sum. So I'm going to say plus 2 minus 1 are my factors. Now, this refers to the zero product rule, which if you haven't seen that previously. Zero product rule says if two values multiply together to make 0, then either the A is the 0 or the B has to be equal to 0. One of those two values has to be 0 in order for the product to be 0. So that's where we're at here. We've got x plus 2 is a value, x minus 1 is a value. When you multiply them together, the result is 0. Therefore, based on that zero product rule, x plus 2 is 0, or x minus 1 is the 0. And I can solve that. I can say minus 2. So that one generates x equals minus 2. And this one is going to generate x equals 1. So I've found two answers, but I have to double check. So I've got to verify at this point. So I've got solution and solution. And to verify whether these are real solutions, I have to go back and look at my original equation and the original denominators. So verify with the original denominators. So the original denominators were x squared minus x and x minus 1. Okay, so if I substitute now, if I put a negative 2 into each of these equations, or each of these expressions, excuse me, then this one, negative 2 times negative 2 is 4. 4 minus negative 2 is 6, so that's fine, that works out to 6. And then here I would end up with negative 2 minus 1 is negative 3. That's fine, that's a real value. So this, x equals negative 2, generates real values. If I took 1, however, and plug it into each of these, 1 squared minus 1 is 0. And 1 minus 1 is 0. So this one is actually not allowed. We call this one an extraneous root. Meaning it is not actually allowable. Algebraically, it comes out of doing the algebraic steps, but it generates an impossible denominator value of 0. 0 denominator. We don't like that. 0 denominator indicates an impossible value, a non-real value.